Hi students, how are you? Today we are going to discuss relative velocity in two dimensions. Already we have seen relative velocity in one dimensions. Now let me take that same concept of relative velocity in two dimensions. So the concept wise, formula wise, same thing, and how we are going to handle and how we are going to apply that relative velocity to the two-dimensional motion we are going to see today. Let me take one example. Have a look at this. Whenever two bodies are moving in two different directions, say for example, this body is moving with a velocity of 3 meter per second along x direction. Let's imagine this body A, this body is moving with certain velocity 3 meter per second. This is the first body, or let me take it is A. Velocity of this A is equal to 3 meter per second. Similarly, another body is moving along y direction. Let me take it is in this way. Velocity of B is equal to 4 meter per second, but it is along y direction. Now the question is relative velocity of A with respect to B. Relative velocity of A with respect to B, which means VAB we are supposed to find. VAB is equal to, this is the question, velocity of A with respect to B. And here we know that velocity of A with respect to B is equal to VA minus of VB, VA minus of VB. This is the usual formula we have. Now let me take here VA minus VB, which means this one VB we have, minus of VB we do not have. So therefore we have to consider this negative vector here. Minus of VB it is, minus of VB it is. This minus VB and resultant is in this way. Resultant of this one VA and VB will be in this way, will be along this direction. Resultant will be along this direction. Okay. Now it is a VAB. It is VAB. Magnitude wise, how do we solve? Magnitude wise, how do we solve? Means vector wise also have a look at this. VAB bar is equal to VA as 3i cap along x direction minus of VB. This is nothing but 4j cap. 4j cap. It is moving along y direction. So why do you take negative sign? Why do we take negative sign? Means this body is moving along y direction, but we have the formula VA minus VB, so therefore we are taking negative vector of that velocity. Okay, right. Now in this case, vector wise this is the formula, and magnitude wise what's the value of VAB? Means VAB is equal to square root of, we all know that square root of a square plus b square formula. If it is in the form of ai cap plus b j cap, you can write. So this is equal to 3 square plus 4 square is equal to 25. Square root of 25 becomes 5. So 5 meter per second is the relative velocity. This is equal to 5 meter per second. Okay. Now sometimes they'll ask the question, what's the direction of this relative velocity? Direction of this relative velocity. If you take tan theta expression in this way, tan theta formula, tan theta to make to find the direction, tan theta. So this tan theta is equal to, what's the usual formula? Opposite side by adjacent side, which means direction. For direction, if you want a direction, to find the direction, use this concept of tan theta. Tan theta is equal to opposite side. Theta opposite side means this one. Magnitude wise these two are same, opposite side. So you can write 4 by 3. So if tan theta is equal to 4 by, the adjacent side is 3. Adjacent side is 3. And now look at this. Tan theta is equal to 4 by 3 means we can find theta value. This theta value is equal to 53 degrees. So this relative velocity is equal to 5 meter per second at an angle of 53 degrees with the x-axis. Okay, right. So in this way we can find relative velocities of two bodies, two bodies in the two directions, 2D, right? Okay, fine. Same question if they ask relative velocity of B with respect to A, if this is the question. Same, if this is the question. Let me take the same question. Direction of minus of VA. This is the direction of minus of VA. Okay, then here, what is the direction of this VBA and what's the magnitude of VBA means? We have to take the diagram once again so that we'll have the clarity. Look at this. Okay, then. Here is the velocity of A, which is equal to 3 meter per second, and this one is VB, which is equal to 4 meter per second in this way. Now here, this one is minus VA and it is VB. We are supposed to find VBA here. This VBA means VB minus VA. VB minus VA. This is the formula. What is the formula for VBA means? Here it is. VBA is equal to VB minus of VA. VB minus VA. Okay. Then here, look at this. VB minus VA, if you take, here it is equal to VB is equal to 4 J cap. VA is equal to minus of 3 I cap. Vectors wise, this is vector notation. When it comes to magnitude wise, same, it is square root of 4 square plus 3 square, which is equal to 5. Magnitude wise, both are same. In the last session also we have seen relative velocity in one dimension also we got the same. Magnitude wise, the values are same. Directions wise, they are opposite. Now look at the direction. VB minus VA. VB minus VA, this one. So here it is. VB minus VA in this way. This is the relative velocity. VBA. Okay. Now if you want to find the direction with the x-axis, theta we have to find. Okay. Or this one, tan theta is equal to, same concept we can use, opposite side here in this way. Just like this. So this is equal to 4 by 3. Once again, this theta is equal to 53 degrees. As we know, tan 53 is equal to 4 by 3 and tan 37 is equal to what? 3 by 4. These are the standard values we must remember to solve this kind of questions. Okay, right. Now, relative velocity in two dimensions we have seen here. The first one is, look at this, VAB we found. Formula wise it is same, VA minus VB. Here it is, VA minus VB we got, and here is the method. And VBA, if you want to find, follow this same thing. Magnitude wise is same, direction wise we got opposite direction. Okay, so this is what the relative velocity in two dimensions. But some special cases are there. Usually questions will be framed on boat, river, or a swimmer and water, or umbrella and the man, or we can say rain umbrella problems. These are all related to relative velocity in two dimensions. Step by step we'll see. So the first one is boat, river problems we will see. First we'll take the concept and then we will solve some questions relevant to that. Okay, right. So first let me take the concept of boat and river. So to understand the concept of boat, river problems, first basic terminology we need to understand. What are those terms means? Here, this one is VB, means velocity of the boat, with respect to ground, or we can say absolute velocity, of the boat. Similarly, this one, velocity of the river, with respect to ground. with respect to ground, or we can call it as the absolute velocity of the river. Next, velocity of the boat with respect to river, VBR, or with respect to water, velocity of the boat, velocity of the boat with respect to a river, or we can say with respect to water, with respect to river or with respect to water. These are the basic terms we should understand first, then only we can answer the questions or we can understand the concept. So the basic terms, velocity of the boat or absolute velocity, and then velocity of the river or velocity of the water also we can call it, and then velocity of the boat with respect to river or velocity of the boat with respect to water. Right. Now imagine if a boat is moving on the surface of the water. Boat is moving on the surface of the water. So then we have two kinds of situations. First one is downstream and upstream, which means in the direction of water if the boat is moving, that is downstream, or in the opposite direction of water it is moving, that is upstream, and crossing the river. These are the three situations we have. First, let me take downstream and then upstream. Right. Look at this. Downstream, first of all. Downstream. Here, in this way, a water is flowing. In a river, water is flowing with certain velocity, with certain absolute velocity. Let me take this is the velocity of water or velocity of the river. And next, if you take a boat which is moving downstream, downstream means velocity of the boat and the velocity of the river both are in the same direction. Now we are assuming this boat with respect to water, it is VBR. With respect to water, it is VBR. With respect to water, or sometimes they'll confuse you with the terminology with respect to still water. A boat can travel with respect to still water or with respect to water, both are same. Okay then. Now here, these are the terms given. So what is the velocity of the boat, absolute velocity of the boat or boat velocity with respect to ground? That's the question. Suppose. Now here, VBR is equal to, according to the concept of relative velocity, VBR is equal to VB minus of VR, or this can also be written as VB is equal to VBR plus VR. This is the velocity of the boat with respect to ground, downstream. Now, as these two are in the same direction, we can write this as VB is equal to VBR plus VR. Okay, so velocities should be added. That is because platform is water here. This water itself moving. Water is moving, and also over the surface of water, this boat is also moving. As a result, we are getting this addition of velocities. In 1 second, water is traveling with VR, boat is traveling over the water with VBR. What is the velocity of the boat with respect to ground mean? This one, summation of the two velocities. Okay, right. Next, suppose if we want to find the time taken by the boat to travel some distance downstream, let me take a T1. Time taken by the boat to travel distance d downstream. So this is time taken is equal to distance by velocity of the boat, nothing but distance by velocity of the boat with respect to river plus velocity of the river. This is the formula to find the time taken by the boat downstream. Okay, right. Next we have upstream. Upstream in the sense right. Okay. Fine. This is a downstream concept, and when it comes to the upstream, boat travels opposite to water direction. Here we have the same kind of example. This is the water flowing with certain velocity in a river. This one is the direction of water flow in a river, or we can say magnitude as VR. And on the water surface or in a river, this boat is traveling in this opposite manner. Velocity of boat with respect to river. Velocity of boat with respect to river. If you observe the two diagrams, you can understand. Boat direction is opposite. Boat direction, velocity of this boat is opposite. So, okay, now let me take upstream here. Upstream means the boat is traveling opposite to river velocity. Here it is VBR. Now in this context, we have to imagine velocity of the boat as the positive and velocity of the river as negative, because river is moving in the opposite sense, opposite direction. Now in this context, VBR is equal to VB minus of VR, or we can write this as VB equal to VBR minus of VR. When it comes to magnitudes, magnitude wise, VB is equal to VBR minus of VR. VBR minus VR, that is because these two are in the opposite manner. Now, if we want to calculate the time taken by the boat to travel a distance D upstream, right? So here time taken by the boat to travel a distance D, upstream is T2 is equal to distance by velocity of the boat. Distance by velocity of the boat means with respect to ground, which is velocity of this one, VBR minus of VR. Magnitude wise, this one, VBR minus VR. Okay, right. Now, let me take one question on this upstream and downstream so that you can understand what is upstream and downstream. Okay, right. So look at this question. A person can swim in still water at 5 meter per second. He moves in a river of velocity 3 meter per second. So here few things we need to observe. What are those means? Look at this. A person can swim in still water at 5 meter per second means velocity of the boat with respect to river. Boat or the swimmer or the man with respect to river is 5 meter per second. And velocity of the river, absolute velocity of water or river is equal to 3 meter per second. It is given. Now what we have to find? First down the stream and next same distance up the stream, the ratio of times taken we have to find. So down the stream we have velocity down the stream, time taken D by VBR plus VR. Time taken for the upstream D by VBR minus of VR. Now they are asking us to find the ratio T1 by T2 is equal to D by VBR plus VR all divided by D by VBR minus of VR. Or we can write this directly as VBR minus of VR, VBR minus VR by VBR plus VR. That is equal to, here we have 5 minus 3, 5 minus 3 by 5 plus 3, which is equal to 2 by 8, can be 1 by 4. 1 by 4, here is the option. Third option is correct. Third option is correct. Okay. In this way, we can solve the question based on downstream and upstream. Okay. And the next concept related to boat river is crossing the river. Boat crossing the river is our next concept. Okay. Right. Boat crosses the river. Boat crosses the river. First, let me take the concept and then we'll discuss question solving methods and all on this topic. Okay. Right. So here we have this kind of a situation. Imagine a river is flowing. Let me take, this is the velocity of the river. Absolute velocity means this velocity, in the sense the river is flowing in this direction with a magnitude of VR. Okay. So here from this point, one bank, from this point, from one side of the river, one bank of the river A, in this way, with this, a boat has started with certain velocity in this way, with certain velocity VBR, velocity of the boat with respect to river, velocity of the boat with respect to river. With what angle, sir? With a vertical. Let's imagine with a vertical, it is some angle, it is subtending angle theta. Okay, right. Now, if this boat is traveling along this direction continuously in this way, this direction, this is the direction. Now, what is the absolute velocity of the boat? Which means, what is the velocity of the boat with respect to ground? That's the concept. So, right. So, here this VBR can be resolved into two components. What are those? What are those? Here it is. This one VBR can be resolved into two components. What are those? This one VBR sin theta, and this one is VBR cos theta. VBR cos theta. Okay, this one is VBR cos theta. Now tell me, what is boat velocity in terms of vectors? In terms of vectors, this VBR can be written as minus of VBR sin theta I cap plus VBR cos theta j cap. This is the velocity vector. And what is the river velocity? Means VR bar is equal to VR I cap. It is traveling in the x direction. So what is the overall velocity along x direction and overall velocity along y direction? So here Vx is equal to along x direction. We can write this as VR minus of VBR sin theta. VR minus VBR sin theta. So why do you take, sir, negative? Means velocity of the river is in this way, but this horizontal component of the boat is in this way. These two directions are in opposite manner. So we are taking VR minus of VBR sin theta. And similarly, along y direction, if you take Vy is equal to only y component is this one, VBR cos theta. VBR cos theta. Okay. So here I am assuming the width of the river as D. Here width of the river is equal to D. Now you tell me, what is the time taken to cross the river? Means in this case, time taken to cross the river T is equal to distance by velocity. Along this y component, that is only VBR cos theta, or you can write this is Vy. So time taken is equal to D by VBR cos theta. This is the time taken by the boat to cross the river. Okay, T is equal to D by VBR cos theta. Okay, then here what is the absolute velocity of the boat? Absolute velocity of the boat means in this way, VBR is equal to VB minus VR, or this VB is equal to VBR plus VR. This is the absolute velocity of the boat. Absolute velocity of the boat. Okay, right. So here, imagine this has traveled some horizontal distance. The boat has traveled horizontal distance. Then what will be the horizontal distance traveled by the boat? What will be the horizontal distance traveled by the boat? Means this x is equal to, okay, x is equal to velocity as this one, VR minus VBR into sine theta into time. Or you can rewrite this as VR minus VBR sine theta into t value given to you as d by VBR cos theta, d by VBR cos theta. This is the horizontal distance traveled by the boat in a given time interval, or while crossing the river. This has traveled horizontal distance in this way, x. Okay, vertical distance is d, width of the river. Width of the river is d, so the time taken is this one, t equal to d by VBR cos theta, and horizontal distance traveled in the direction of river is given by, this is VR minus VBR sine theta into d by VBR cos theta. Sir, why do you take minus VBR sine theta here? If you ask a question, that is, this VBR sine theta and VR are in the opposite manner. This component, velocity of the river, and this VBR sine theta are exactly opposite to each other. So therefore, we are getting VR minus VBR sine theta. Okay. In this context, usually we will get two types of questions. The first kind of question is, what is the minimum time taken to cross the river? That is first kind of question. And second kind of question is, if the boat wants to reach the opposite bank exactly, what should be the angle? What should be the angle with which the boat has to be started? These two kinds of questions we will get usually on this concept. Okay. So let me take those two situations here. First of all, minimum time. Right. So let me take the concept of minimum time for the same. Minimum time. Right. Okay. So in this diagram, the time taken by the boat to cross the river, minimum in the sense, here the time t is equal to, time taken is equal to t is equal to VBR, sorry, time taken is equal to d by VBR cos theta, Now in this context, if this denominator is maximum, automatically numerator will be minimum. So this VBR cos theta will be maximum when cos theta is equal to 1. If this is equal to VBR, or what we can say, cos theta is equal to 1, then theta is equal to 0, or we can say, if the boat is rowed exactly perpendicular to the river flow, then the time taken by the boat to cross the river will be minimum, which means this becomes minimum. T minimum is equal to d by VBR. This is the formula. Time taken will be minimum. T minimum is equal to d by VBR. And here, what's the direction? This boat has to be rowed in which direction? Perpendicular to the river flow. Always if the boat is aiming exactly opposite bank, then only it is possible and the time taken will be minimum. So what is the velocity diagram for this, if you ask? This is the velocity diagram. This is the velocity diagram. Here it is velocity of the boat with respect to river and velocity of the boat with respect to ground or absolute velocity of the boat, and here it is velocity of the river, velocity of the river. Okay, so in this way, and here sometimes they'll ask the question, what is the drift produced? Drift produced means horizontal distance traveled by the boat in reaching the opposite bank. What is the horizontal distance traveled by the boat? Means here this one we can write x is equal to velocity Vr into T minimum. T minimum already we found one formula. X is equal to velocity of the river into minimum time taken by the boat to cross the river. This is one kind of problem. They'll ask the question, what is the minimum time taken? Minimum time taken means whole velocity should be along which direction? Along the direction, always that boat has to aim opposite bank. Then only the time taken will be minimum. Okay, right. So this is one kind of question. And the second kind of question on the same concept is, to reach the opposite bank exactly, what will be the time taken? Here it is. Minimum distance method. Minimum distance. Look at this. Here it is. Position A, exactly opposite to this, opposite to bank, this boat has to reach. So to reach this position, this boat has to start with some angle, with a vertical. This is velocity of the boat with respect to river, and here it is theta. This one is velocity of the boat with respect to ground. It is velocity of the river. So in this context, they'll ask the angle with which the boat has to start to reach the opposite bank exactly. So therefore, in this context, here it is time taken is equal to distance, means width of the river by velocity of the boat with respect to ground, or this can be written as d by this VB is equivalent to VBR cos theta. This VBR can be resolved into two components. Already we have seen this one is cos theta component and it is sin theta component. So here d by VBR cos theta, this is the formula for the time taken to cross the river, and this time taken will not be the minimum because the boat is traveling with some angle with a vertical. Okay, right. Now in this case, what is the theta value? Theta value means, look at this. Here it is VBR sin theta, and this is the river, velocity of the river. These two are in the opposite manner. If these two components cancel out each other, then the whole velocity of the boat will be in the vertical direction. This thing has to happen, which means to reach the opposite bank exactly, the horizontal components of velocity of the boat and this river velocity has to be cancelled out. So which means here this one VBR sin theta minus of VR equal to 0, or you can write this as VBR sin theta equal to VR, or this sin theta is equal to VR by VBR. Sin theta is equal to VR by VBR. With this angle, that boat has to start its journey and always it has to aim with that angle. Then only it will reach the exactly opposite bank of the river. Okay. These two kinds of questions usually we will get on this boat river problems. Okay. What are the two? First one is minimum time taken, means the path along which the time taken is minimum, and the path along which the distance is minimum across the river or to reach the opposite bank exactly. These two kinds of problems usually we will get. So what are the formula here? Time taken is d by VBR cos theta along minimum distance, along minimum distance. If it is minimum time, that's a different formula, that is d by VBR. And here it is, what the angle means, sin theta is equal to VR by VBR. This theta is with the vertical, and with the river flow angle, total angle with the river flow, total angle with the river flow is given by theta plus 90, or we can say 90 plus sine inverse of this VR by VBR. Okay, this is the total angle with the river flow, right? We'll see some questions based on this river boat. Okay then. So all the concept has been summarized here. Whenever the boat crosses the river in a shortest time, t is equal to d by VBR cos theta, or this one, minimum time taken by the boat to cross the river is d by VBR. Here theta is equal to 0, which means the boat is aiming always the opposite bank. So this is the formula. When it comes to drift produced, here it is drift produced. X is the drift produced, that x is equal to horizontal velocity or Vx into time taken to cross the river. And here shortest path means along this vertical direction if the boat is traveling, means with real time velocity or absolute velocity. Here it is, this one, with which angle the boat has to row, here means sin theta is equal to VR by VBR, opposite side by hypotenuse VBR. Time taken is equal to d by VBR cos theta, which is equal to d by VB, or velocity of the boat with respect to ground. Now let me solve some questions on this concept so that you can understand. We have selected some questions, very good questions. So look at this first one. A man can swim in still water at a speed of 6 kilometers per hour. Means the first thing you have to identify here is still water 6 kilometers per hour, which means velocity of the man with respect to water, or VBR is equal to 6 kilometers per hour. 6 kilometers per hour is given, and he has to cross the river and reach just opposite point on the other bank. This one. So therefore we have to find, the person is traveling across the river along the shortest path formula we have to apply. If the river is flowing at a speed of 3 kilometers per hour, what we have to find? He has to swim in the direction we have to find. As we have seen the diagram for this kind of situation, here it is the direction, velocity of boat or the man, and here is the angle with which he is swimming, velocity of the boat with respect to river, velocity of the river. So here sin theta is equal to, already we have seen here, we summarized the formula also. Here it is, sin theta is equal to VR by VBR. This is the formula. Now let me use that formula here. Sin theta is equal to VR by VBR, which is equal to, VR is given by 3, and that is equal to 6 kilometers per hour, 1 by 2. Sin theta equal to 1 by 2 means theta is equal to 30 degrees. So with the vertical it is 30 degrees. With the river flow it is already here 90 with the river flow. This is the direction of river. With the river flow 90 plus 30, total angle is equal to 120 degrees with the river flow, which means here it is 30 degrees with the river flow. So this first option is a trap. You should be careful while taking the first option. 30 degrees with the vertical or with the river flow. 30 degrees is with the vertical, but here it is given as 30 degrees with the river flow. That is a wrong option. That's a trap. Now Coming to the second, 60 is a wrong answer and 135 is also wrong answer. Only the thing is, which is the correct one? 90 plus 30 total angle is equal to 120. This is the answer. Okay. So 120 degrees with the river flow is the correct answer. Okay. Right. Next question we can take. Hope you understand. Velocity of the man with respect to river is given. Velocity of the river is given. And this person has to travel to opposite bank exactly in this way along this path A to B. Right. So we are supposed to find the angle with which the person has to swim. So this is the angle with x-axis, or we can say with the river flow. 90 degrees plus 30 degrees, total angle is equal to 120 degrees. Okay. Right. Next question we will take on the same concept. Look at this. Look at this. A man can swim in still water at a speed of 6 kilometers and he has to cross the river and reach just opposite point on the other bank. If the river is flowing at a speed of 3 kilometers per hour and the width of the river is 2 kilometers, the time taken to cross the river. Here we have certain values. This one, man can swim in still water at 6 kilometers per hour, which means velocity of the boat with respect to river, means man with respect to river is equal to 6 kilometers per hour. 6 kilometers per hour it is given, and he has to cross the river and reach just opposite point on the other bank, which means is it the shortest path or shortest time? It is the question related to shortest path because person has to reach the opposite bank. Next, if the river is flowing at a speed of 3 kilometers per hour, velocity of the river is equal to 3 kilometers per hour. And the width of the river is 2 kilometers. These are the values given. Width of the river is equal to 2 kilometers. Velocity or the speed of the river is 3 kilometers. The time taken to cross the river. So we summarized this concept. Look at this. What we have to find here? We have to find the time taken. T is equal to d by VBR cos theta or d by VB, absolute velocity of the man. But here velocity of the man with respect to water is given. So therefore, we have to find first theta and then cos theta and then we can substitute. Let me take the formula first. Here it is. What's the formula for sin theta here? Sin theta is equal to VR by VBR is the formula. VR is equal to 3 and VBR is equal to 6. This is equal to 1 by 2. Theta is equal to how much? 30 degrees. If theta is equal to 30 degrees, what is cos theta? Cos 30 is equal to root 3 by 2. This we know. And now time taken is equal to d by VBR cos theta. This is equal to d is equal to 2 kilometers. VBR is equal to 6 kilometers. Cos 30 is equal to root 3 by 2. And this can be written as in this way. This is equal to 2 by 3 root 3. 2 by 2 root 3. Or this can also be written as 2 by this 3 which is outside the square root can be taken inside the square root as 9, 3 square. So already 3 is there in the square root. This can be written as square root of 27. So 2 by 27 is the answer. Time taken by the man to reach the opposite bank exactly at opposite point, that is given by 2 by root 27. Okay, which option? Means this one, second option is correct. First option is 2 by 27. You should be careful while selecting the first option. That is because first option most of the times it will be a trap, right? So while selecting the first option, again and again you recheck your answer whether it is correct or not. So here in this question, second option is correct. That is 2 by root 27. Okay, right. Now let me take another topic on relative velocity, that too in 2 dimension. That is rain umbrella problems or man and rain problems. These are also related to relative velocity. And here we will see how this concept is applicable here. Look at this. If a man is standing in this way in a rain, imagine this rain is appearing to the man vertically. This man is at rest. Imagine this man is at rest. So this man is feeling the rain is appearing to him vertical. Suppose if the man is running, this is a usual and common experience to all. If we are traveling on a bike on a rainy day, we feel that the raindrops are falling on our face at certain angle. That is because of our speed. As we increase our speed, that angle increases. Okay. So if we reduce the speed, that angle decreases. If you are at rest, the rain appears vertical. If it is vertical, right? So this is usual and common experience. If this man is at rest, this is the experience of the man. Okay. Now suppose if the same man is running at certain speed, this man will experience the rain in this way. This man will experience the rain with certain angle with the vertical in this way. So this is the usual and common experience to all. At which angle this rain is appearing to him means at an angle alpha with a vertical. So in the questions they'll ask, what is the angle with a vertical this rain is appearing, or we can say at which angle the man has to hold the umbrella to protect himself. This kind of questions they'll ask. Okay, right. We will see the concept here. Now imagine this man is running at a speed of VR, velocity of the man, here in this way. Velocity of the man in this way. Now he is running at this speed. So imagine this rain is appearing to him vertical, or this rain is appearing to him at some angle. Here it is this one Vm minus of Vm, and here it is velocity of the rain actually, and this rain is appearing to the man in this way, velocity of the rain with respect to man. That is because, look at this, we know that relative velocity VAB is equal to VA minus of VB. Similarly, velocity of the rain with respect to man is equal to VR minus of Vm. So we are taking minus of Vm here. Okay. And how this rain is going to appear to the man means in this way, at some angle alpha with a vertical, and here you can take beta with a horizontal in this way. Okay. Okay then. So to the man, how it appears? Imagine this rain is in this way extended, VR, velocity of the rain with respect to ground, and this one is velocity of the man. So therefore their resultant in this way. Their resultant is in this way. Velocity of the rain with respect to man. Okay. Similarly, you can extend the line. So at this angle, we have to hold the umbrella. Okay, right? So here, if you want to find that angle with a vertical, tan alpha is equal to only magnitudes. So Vm by this one horizontal is VR. This one is the angle at which we have to hold the umbrella with a vertical. Tan alpha is the angle made by the relative velocity of the rain with respect to man. Vrm with a vertical, right? Okay. Now this one tan beta is equal to angle with a horizontal. This is equal to opposite side is VR and adjacent side is Vm. In this way, we have to hold the umbrella. So this man has to hold the umbrella. If he is moving with certain velocity at an angle beta with a horizontal. Okay. So let me take some questions on this so that you can understand. Okay. Right. A man is walking with 3 meters per second due east. Rain is falling vertically downwards with speed 4 meters per second. Find the direction in which man should hold his umbrella so that rain does not wet him. Rain does not wet him. So we are supposed to find the angle. As we have seen the concept, here is the situation. Here is the situation. Actually, it is raining. Man is running at a speed of what? 3 meter per second in this way. Velocity of the man is equal to 3 meter per second. And minus of Vm will be in this way. Minus of Vm is equal to, this is the direction. Actually, vertically downwards. Rain is falling vertically downwards in this way. Velocity of the rain, actually, with respect to ground. Now, how this rain appears to the man? How this rain appears to the man in this way. Okay. Now we have to find the direction in which man should hold his umbrella so that rain does not wet him. Let me take this is alpha. This is alpha, and this man has to hold the umbrella, right? So here, what is the angle here? Tan alpha is equal to opposite side VR and adjacent side is Vm. VR is equal to relative velocity of the rain. Velocity of the rain is equal to 4 and the velocity of the man is equal to 3. This is equal to alpha equal to how much? 53 degrees. Alpha is equal to 53 degrees with the horizontal. So with the horizontal 53 degrees, at 53 degrees, this man has to hold the umbrella. Or with the vertical, automatically 90 minus 53. So with 37 degrees, this man has to hold the umbrella, right, with the vertical. Clear? Right. This is the concept of relative velocity in 2 dimensions. Right? Thank you.